So what we're looking at here is the exam solutions vodcast for the 2016 exam 1 for math methods. Okay, let's make a start. Okay, let's look at the first question. So what you had to do is to express the 1/25 as 5 to the minus 2. Once we have both of the bases the same, we can equate the two indices, so we can let 2x plus 3 equal negative 2, and then when we solve this we get x is equal to negative 5/2. In this question, what we need to do is to use our log laws to simplify, and what we're trying to do is to express this with one log term on each side of the equals sign. So we notice that we've got a 2 there, that comes into the front, or comes in here, makes it x to the power 2 there. And in the meantime, nothing else has changed on the first line. Let's have a look at the next line. Now, when we see that there's a plus sign there, we know that we can multiply the 3x and the x squared together. That's what's happened here. When we see this minus sign here, we understand that now we can do divided by 6. And over here, remember we've used the idea that log 2 is equal to 1. So we know that that would have been negative 1 times log 2. We've just brought the minus 1 in here and made that 2 to the minus 1. Well, what that means is that now we can equate these two to each other. So we can say that 3x cubed over 6 must equal 1/2. Why 1/2? Because 2 to the minus 1 equals 1/2. Once we've done that, it's just a matter of rearranging, and so we get x cubed is equal to 1, and then we take the cube root of both sides and we get x is equal to 1. Now let's have a look at the marking scheme for this question. So you can see that it says one method mark was allocated for getting any correct log law somewhere. That's pretty generous. So long as you had a correct law somewhere, you were given a mark, and then one answer mark for getting the correct answer, of course. Okay, so as it turns out, this question was quite poorly done, so let's have a closer look at it. Well, what we're looking for is base of 2, and we think to ourselves, aha, that's the same base, and when one of the powers is double the other one, that's when we can make a substitution. So we make the substitution, we say let a equal 2 to the power of x. That means the first term is going to become a squared minus 2 times a, and the 8 comes across the other side, minus 8 is equal to 0. What this reveals is a quadratic, which we're now going to have to factorise. When we factorise, we get a is equal to, or a minus 4 times a plus 2, and we get a is equal to 4 or negative 2. But we're not finished, because what we need to do now is to actually work out what the x is equal to. So now we resubstitute and we say 2 to the x is equal to 4, and 2 to the x is equal to negative 2. Now from here, we can just say, oh, well, therefore x must equal 2. But with this one, 2 to the x is never equal to a negative number. It's always going to be a positive number, and so there can't be any solution to the equation 2x equals negative 2. And so we write down that there's no solution for that one. Therefore, x equals 2 is the only possible correct answer. Well, as it turns out, this one was quite well done. We were quite pleased with this. So what happens was the 2 causes the amplitude to change. The amplitude now becomes 2, so that everything is dilated away from the x-axis by a factor of 2, and the 1 causes everything to translate up 1. Well, what this means is we get a graph which would have been going through the origin, now gets translated up 1 unit. And the same thing happens across the whole graph. So this endpoint here would have been there, and so it's been translated up 1 unit as well. From there, it's a matter of doing quite a bit of work, and we know, for example, that the turning point is going to be halfway between this one and this one, and so the turning point has to be at pi on 2. We already know that the 2 had caused the dilation of factor 2, so the maximum value would have been 2, but when we add 1 to it, the maximum value is now 3, so we know that that coordinate must be pi on 2 and 3. In a similar fashion, we know the minimum point, this one down here, that must be halfway between 0 and negative pi, so it's going to be at negative pi on 2. We also know that if we just looked at the 2, the minimum would have been -2, but because we've added 1, we've shifted everything up 1 unit. Now the minimum is -1. Okay, they were the easy ones to work out, and also the endpoints we've already spoken about as well. But in the meantime, the x-intercepts, how did we possibly get them? Okay, so what you've actually got to do is a bit of work here. You've got to do 2 sine x equals -1. So we've transposed this original equation up here to make that 2x equals -1. We've got to divide both sides by 2, so it's -1 on 2. And then we've got to try and find out what x values make this a true statement. So we need to find the basic angle, and that's equal to inverse sine of positive 1/2, and that's equal to pi on 6. Now, in the meantime, we've got a bit more work to do because we notice that this was negative. If that's negative, what that means is our solutions would have been in quadrant 3 and quadrant 4. So you might have therefore thought that the quadrant 3 angle was going to be, let's see, pi plus the basic angle would have been 7 pi over 6. And quadrant 4 angle would have been 2 pi minus the basic angle. That would be 11 pi over 6. But then you realise, hang on, the maximum value in the graph was pi. So what am I going to do? Well, I'm going to subtract 2 pi from that one. I'm going to subtract 2 pi from that one. And that's going to give me these two values right here. So let's do that. So when we go to 7 pi on 6 minus 2 pi, remember that's 12 pi over 2. 7 minus 12 is -5. That's this one here, -5 pi over 6. In the meantime, if I've got 11 pi over 6 and a minus 12 pi over 2, 11 minus 12 is equal to -1, and that gives us our negative pi over 6 there. And so that's how you work out what the intercepts are equal to. So in this particular question, we had to solve the equation. It's a little bit similar to what we saw in the previous question where we had to find the x-intercepts of the graph. So the first thing we need to do is to take the 1 across the other side. It becomes -1. Next thing we need to do is to divide by the root 3. Now we have to find the basic angle, so we do inverse tan of positive 1 on root 3, and we remember that that's equal to pi on 6. Coincidentally, it was the same basic angle as the previous question. Doesn't matter because the quadrants are going to be different this time. So this time we're working in quadrant 2 and quadrant 4 because tan was negative. We know that tan is negative in the second and fourth quadrants. So how do we work out what those angles are going to be equal to? So the second quadrant is pi minus the basic angle. Pi minus pi on 6 is equal to 5 pi on 6, and the fourth quadrant angle is 2 pi plus the basic angle, no, beg your pardon, minus the basic angle, stupid me, and so that's going to give us 11 pi over 6. And we can see the marking there was you needed to work out in some way what the basic angle was equal to, and you also needed to get the correct answers. Notice that there's 2 marks there, one for each of those correct answers. So you did pretty well with this one. So we had to find the second derivative. First thing we needed to do was to realize that 4 over x squared could have been written as 4x to the minus 2. That helps us with our differentiation. So when we do the differentiation, that just becomes 3x squared, easy peasy. That becomes just minus 4, and this becomes minus 8x to the minus 3. And then we do a very rare thing in an exam. We RTQ. And what does RTQ mean? It means read the question, because the question said we had to express with positive indices. Well, if we have to express with positive indices, that makes that answer wrong. So we're meant to write the answer with positive indices, as you can see. However, it might be a good idea to leave the answer in this form so that we could do the second derivative. Because when you do the second derivative, 6x, the minus 4, remember when you differentiate a constant, becomes 0. And over here, so we've got 3 times 8, which is 24. It's a negative times a negative, so it's plus 24, x to the minus 4. And then once again, we're expressing our answer with positive indices, so that's our final answer there. Okay, let's go. And so in this particular question, we're told what the gradient function is equal to, and we're going to try and find the original equation. So we know that dy dx is equal to, notice what I've done there, 3x squared plus 6x. So I've expanded the brackets there. Now in the meantime, if I want to find out what y is equal to, it's equal to the antiderivative. Remember that sign means the antiderivative of 3x squared plus 6x dx. And remember, don't forget the dx. Okay, so when we do the antiderivative, that's going to give us 3x cubed over 3, but of course the 3's cancel out, and that gives us the x cubed that we see there. And in the meantime, you've got 6x squared, divide by the new power, the 2 and the 6 cancel out, and that's why that's 3x squared there, plus the ubiquitous c. And we need to find out what that c is equal to. Is there anything else which can help us? Well, there certainly is. This is a little clue here that tells us when x is equal to 2, y is equal to 21. So we substitute this into our newly found equation for y. Once we've done that, that enables us to find out that c is equal to 1. Once we've got that, we do need to remember to finish off the question and write down what the equation is, and it was equal to x cubed plus 3x squared plus 1. So in this question you had to be looking fairly closely for the clues and understand what it means when it says the tangent is parallel to the straight line. If it's parallel to that particular line there, it must have the same gradient at the point that we're discussing. So we know that if it's in the form y equals mx plus c, the gradient must be equal to 4. So if parallel, m is equal to 4. Now, in terms of our original equation, what y was equal to, that means that we know that at the point that we're considering, y dash is equal to 4. Because the gradient's equal to 4, y dash is equal to 4. So we derived this expression that gives us 2x minus 4 is equal to 4. We add 4 to both sides, gives us 2x equals 8. Divide both sides by 2, and we get x is equal to 4. So we've got our first value as our x value. Remember the question said you had to find the coordinates. So we're not finished until we find out what the coordinates are. So we need to find out the y value as well. How do we find this? By subbing back into the original equation, the one which is telling us what y is equal to. So when we sub it in, we get y is equal to 2, therefore the coordinates are just 4 and 2. Notice you were meant to write down the coordinates, but if somewhere you'd written down x equals 4 or y equals 2, that was still okay. Now in this question we had to determine whether events A and B are independent. So there's a test for this, and the test is events A and B will be independent if probability of A intersection B is equal to probability of A multiplied by probability of B. And this is the best one to use in this particular case because all the numbers are laid out for us. We know what probability of A is equal to, we know what probability of B is equal to, so that if we do 0.6 times 0.8 we get 0.48. What we don't know yet is what probability of A intersection B is equal to. Probability of A intersection B can be found by using our addition rule. It's equal to probability of A plus probability of B minus probability of A union B. We do know this. We know that that's equal to 0.92. And so as it turns out, probability of A intersection B is equal to 0.48. Well, look, they're both equal to each other. Therefore, we can say that events A and B are definitely independent. So that's all pretty cool. Now there is another way of proving this, and the other way of proving this is let's take our rule for probability of A intersection B is equal to probability of A multiplied by probability of B. And how about we just divide both sides? So we do probability of A intersection B divided by probability of B, and that should be equal to probability of A. So this is just the same thing rewritten. Now the eagle-eyed people amongst you would have noticed already that that is equal to probability of A given B. So that if probability of A given B is equal to probability of A, therefore we can say that the events are independent as well. So we know that probability of A was 0.6 Over here, probability of A intersection B, well that's probability of, sorry, A given B, is A intersection B over probability of B. Now we've worked out previously that probability of A intersection B is 0.48. We know from up here, probability of B is equal to 0.8. And so when you do the division there, what you find out is that this cancels down to give us 0.6. And guess what? That's the same as that. So once you've shown that both of those are the same, you have shown that the events are independent. Me, I don't like that way. I much prefer the original way that I showed you. Okay, next slide. All right, let's have a look and see what's going on here. So when we do this question, we need to work out a little tree diagram. And so what we're showing is the Year 9 students, so we're showing the senior students. Because there was 200 Year 9 students, that means a quarter of the population are Year 9, and it means that 3/4 of the population are senior students. So on your tree diagram, you need to have something which would reflect that. In the meantime, we know that 70% of the Year 9s own a mobile phone, so that means that 7 out of 10 will own the mobile phone. So I've got the M circled there standing for mobile phone. We know that 9/10 of the senior students have a mobile phone, so we've circled that one. So the probability that you're going to have a mobile phone means the probability you're Year 9 and have a mobile phone, plus you're a senior and you've got the mobile phone as well. And so you just work all that out and it ends up coming down to 17 over 20, or 85%. If you want to put that in terms of percent, but you don't, because you prefer to write it as a fraction, because fractions are good and decimals are evil, and you always want to be good, don't you? Okay, so when we do the limit question, oh look, by the way, that's cut off there, so it should be x squared plus 4x. Generally speaking, it's just a matter of subbing in the value, unless there's a good reason not to. So let's have a look and see what happens to the first one. If you sub in 4, 4 squared is 16, 4 times 4 is 16, 16 plus 16, 32. Okay, nothing really bad there. So that would be our answer. So just say the answer is equal to 32. But if you're doing the next question and you sub in 3, you've got 3 squared plus 3 minus 12 all over 3 minus 3 is 0. Bad things are happening here. This is a good reason not to just sub in, because when you're dividing by 0, the whole function is undefined, and you don't want that to happen. So what do? Well, you cross that out for a start. And what you do is you factorize the top line, factorize the bottom line if you need to, cancel out the common factors. Now you've got something which, when you sub it in, bad things aren't going to happen. So when you sub 3 in there, you get 3 plus 4, and of course the answer is 7. Okay, so this one's actually open to interpretation because there's actually quite a few different answers which are correct, and your teacher will be able to explain to you which ones were correct and be able to tell you why you've been marked wrong if you've got particular things that have been marked wrong. Okay, so what I did in this question was I took the original expression and I rearranged it to make it 3 over negative x minus 2. Okay, now what I would say is I've got to remember, if I'm talking about the order, there's something which helps me, and this is Dr. T. So if I'm going to write down what the transformations are, I'm always going to talk about dilations and reflections first and translations second. It's a really good habit to get into. I should say that there are other ways of doing this, but flirting with death, and you're really signing your own death warrants if you try and flirt with it and hope that you're going to get the right answers to these. Okay, let's have a look and see what is correct here. So I'm going to look at the 3 first, and I notice that what that does is it multiplies everything by 3, and so therefore this is a dilation factor 3 from the x-axis. Now I did notice creeping in was something that said dilation factor 3 in the x-axis. This doesn't make any sense. You can't write that down, because there are actually 2 ways of speaking about this. One is when you talk about dilation from the x-axis, and one is when you talk about dilation in the y direction. Now if it's in the y direction, that's okay, but you need to say it's in the direction of the y-axis. You can't just say in the y-axis. It makes no sense at all. So you need to get that out of your system right now. In the meantime, What does the minus do? Well, in the same way that if you've got y is equal to x squared, and you know that looks like a parabola, if you've got y is equal to minus x squared, what does that do? It inverts the parabola and so causes a reflection in the x-axis. So that's reflection in the x-axis. And finally, we've got the translations. These are the ones that most people get, provided you've put them in the brackets like this. Is obvious. That's going to be a translation of 2 units in the positive x direction. The plus 4, that's always okay, so it's 4 units in the positive y direction. Okay, once again, could I say to you, you need to ask your teachers to make sure that you're on the right track with that one and find out where you've actually gone wrong if you've lost any marks there. Okay, so we're going to use our Carnot maps for this particular question. We're going to try and find out probability of A intersection B first. Well, in order to do that, we're going to use our addition rule. So we've got probability of A plus probability of B minus probability of A union B. Now, good news is we know A union B, that's 0.8. Good news is we know probability of B, that's equal to 0.5. Bad news is we don't know what probability of A is equal to, but we kind of do, because we know the probability of A dash is equal to 0.4. Therefore, looking at our Carnot map, remember everything has to add up to 1. That means probability of A must be 0.6. As soon as you know that, you know the answer, provided you can actually do arithmetic. And so that comes down to 0.35. Now the next one says you've got to find probability of A intersection B dash. A intersection B dash, well, that's that one there. It comes down there, goes across there, 0.25. So you'll notice there's an H mark. H stands for his, her, also known as consequential mark. So that if you had your Carnot map filled in incorrectly, you at least could have got a consequential mark, even if you had the wrong answer. Just check to see that you haven't been unfairly dealt with in that case. Okay, so in this question we're going to find out probability of A dash union B dash, and we're going to use our addition rule of probability of A dash plus probability of B dash minus probability of A dash intersection B dash. Well, what do we know? We know probability of A dash was 0.4. We know probability of B dash was 0.45. Well, we didn't know that before, but we kind of know that because we know that has to add up to 1. And the other thing we needed to know was what probability of A dash intersection B dash is equal to. So once again, if you got your Carnot map filled in properly, that's pretty easy. So it's just 0.2. So the final answer turns out there to be 0.65. Once again, you'll notice the appearance of H marks here, consequential marks, and that will depend on what you've had for your previous answers. So once again, it's possible to be marked correct, even though you've got an incorrect answer. Just depends on what your previous working showed. Okay, last one here, we've got to find probability of A given B dash. Well, we know that's equal to probability of A intersection B dash over probability of B dash. Notice you got 1 mark already for the correct use of the formula. That's generous because that formula was on the formula sheet, wasn't it? Well, not quite in that form, but pretty close to it. Well, what we've got to do is to find out what A intersection B dash is equal to. There it is, it's 0.25, so that goes on the top of the fraction there. Probability of B dash, well, we already knew that from before, that's 0.45, and now we've got to put this in simplest form. We cancel that down and we get 5 over 9. Okay, in question 10, the first thing we need to do is to point out that original rule was wrong. It should be pi r squared h, and you're told that at the start of the exam anyway. So what we've got to do is to try and show that the total surface area of the cylinder is given by A is equal to 2 pi x squared over 24 pi x. So you'll notice in here there's nothing about the actual height. Well, what to do? Here's what you do. You work out an expression for the total surface area. It's equal to the area of 2 circles. There's the top one and the bottom one, plus the area of the rectangle. That's what goes around the outside of there. Now, because it goes around the outside, this part of the rectangle, when opened up, would be represented by the circumference of the circle, and also the where we're looking at the height is just going to be this y here. So we're going to have to work with that in a minute. So what do we know? We know the area of the circles is pi r squared, so it's 2 times pi r squared, and we've got 2 pi r, that's the circumference of the circle, times the height. Now we sub in the information we know. We know that r is equal to x in this case. It becomes 2 pi x squared plus 2 pi x times the height. Remember, the height is equal to y. This is where you hit a brick wall, because you've got a y that you've got to try and find an expression for. And this is where we use the information that we're given about what the volume was equal to. Now the volume was equal to, I see I've done it up here as well. So the volume was equal to 12 pi cubic centimeters. So here we're going to make that pi r squared. H is equal to 12 pi. So pi x squared y is equal to 12 pi. We need to rearrange this. We cancel out the pi's and we get 12 over x squared. Once we've got our 12 over x squared, we sub it into here, the 12 over x squared, and that leads us to the part that we're trying to show. Okay, now in part B, it said find the value of x for which the total surface area of the cylinder is a minimum. Now remember, when you have a show that question, you're allowed to use the part, even though you hadn't probably worked it out previously. You are allowed to use that 2 pi x squared plus 24 pi over x. So we need to differentiate that expression. We get the 4 pi x minus 24 pi over x squared equals 0. We rearrange this and we eventually get x is equal to the cube root of 6. And so that's our final answer. Or is it? What did it say? It said find the value of x for which the total surface area is a minimum. Yeah, that's what we needed to do. We only needed to find x, so that's the end of the story. So this one said we had to factorize that expression. So when we factorize and we haven't got our calculators, we need to do the process of finding out what one of the factors is first and then doing the polynomial division. So we do that, we do P1, and guess what? It turns out to be equal to 0. Well, that's a relief. That really saves us having to do a whole lot of work, doesn't it? Because if P1 is equal to 0, that means that x minus 1 is a factor. Brilliant. So now we do our polynomial division, x minus 1 into the expression there, that 2x cubed plus 15x squared plus 24x minus 41. And when we go through everything, remember, good sign is if we've got a remainder of 0, that's really good. And there is a remainder of 0. So what that means is the other part of the expression is 2x squared plus 17x plus 41. Now, we need to show that there's only one factor. So we need to show that this can't be factorized. Now, because it's a quadratic, we can show that it can't be factorized using the discriminant. So if we use the discriminant, we get b squared minus 4ac, and we work out that that's equal to negative 39. Importantly, that's a negative number. If it's a negative number, we can't factorize this over the set of real numbers. So there's no solution to that part of the equation. It can't be factorized. That's the important thing. If it can't be factorized, we now know that x minus 1 is the only factor. Okay, all good. Well, I should say the message to you with this question is, just because it's the last question on the exam, don't always assume it's going to be the most difficult. Well, let's see what you had to do. Coincidentally, this was the same expression as what we had in the previous part, and so we had to find out where the turning points were. So how do we find that? We need to find the derivative. We need to let the derivative equal 0. Well, if we need to do that, we need to factorize this. Our first rule of factorizing, take out a common factor. We've done that. Factorize the remaining part, the quadratic, we get x plus 4, x plus 1. From there, we get x is equal to negative 4 and negative 1. And then we go back and read the question again, because we need to find out, were we required to find anything else? Let's see what it says. Find the x coordinates of the turning points of the graph. Oh, look, it didn't say find the y values. It just said find the x coordinates. That means our work is done. So that's actually where we stop with this question. We didn't need to go any further. Okay, well that's it for now. Any further questions, just make sure you ask your maths teachers. Make sure exactly, or do you know exactly what's going on. But that's all for now. For now, may your maths be good maths, and bye for now.